Bowling has always been a popular pastime, but has recently become one of the most popular and well-known sports. Bowling can be traced to ancient Egyptian times, dating back to 3200 BC. Archaeologists discovered collections of objects in an Egyptian child's grave that seemed to be used for a primitive form of bowling. There were several pins as well as a ball that were all sized for a child found inside the tomb. These artifacts were found alongside many others that dated all the way back to 3200 BC. Following this discovery, the next surfacing of bowling was in Germany in 300 AD. This form of bowling took place as a religious ritual to cleanse the soul from sin. However, the first official mention of bowling wasn't until 1366 by King Edward III. The king decided to ban bowling as it was seen as a distraction to archery practice. Eventually, this ban was overturned by King Henry VIII, restoring bowling to England. Various forms of bowling circled throughout Europe, and the popular pastime soon found its way over to America as well. In the 19th century, lawn bowling surfaced in New York and eventually became a method of gambling for Americans. In this form, bowling was played with 9 pins and 1 ball. The gambling became a big issue and was eventually banned in Connecticut. It was then, after this ban, that 10-pin bowling was established. At this point, the game took on various rules and formations throughout the different regions, so in 1875, the National Bowling Association was established to regulate the rules of modern-day 10-pin bowling. With this, American citizens could now compete against each other, all abiding by the same game. In the game of bowling, the bowler has 2 chances to knock down as many pins as possible. If a bowler is able to knock down all 10 pins in one roll, it's called a strike. Knocking down 10 pins in 2 rolls is known as a spare. If a strike is made on the 10th frame, the bowler receives 2 extra balls. 2 strikes in a row is a double, and 3 strikes in a row is a turkey. A perfect game is achieved with 300 points. Some interesting facts that you may not have known about bowling is that bowling is the #1 participation sport in America. When bowling began, it was a men's-only sport. However, in 1917, women started the Women's National Bowling Association, introducing women to the sport as well. Japan is home to the largest bowling alley in the world, the Inazawa Grand Bowling Center, containing 140 lanes. 9-pin bowling is currently banned in every state except for Texas. And about 70 million people bowled at least once in 2011. Now that you've learned a little about the origins of bowling, let's get into the physics. Now to discuss how bowling relates to the first topic of physics: forces, force components, and linear or projectile motion. In the case of a bowling ball, 2 forces typically act upon the ball. These forces are gravitational force and applied force. Gravity acts upon the bowling ball in a downward manner, and applied force acts upon the bowling ball in a horizontal manner. Due to these unbalanced forces, the bowling ball not only accelerates downward, but horizontally as well. As shown in the diagram, as Amanda releases the ball, the applied force propels the ball forward, while the gravitational force will bring the ball downward. These combined forces will result in the ball witnessing an outward curving motion as it falls to the ground. To calculate the gravity force acting on the bowling ball, one must multiply mass by gravity. The gravity on Earth is roughly 9.8 meters per second squared. Therefore, a bowling ball with a mass of 15 kilograms would have 147 newtons of gravity force acting upon it. Once the bowling ball reaches the lane, however, there are now additional forces acting on the ball. Not only is there gravitational and applied force acting on the ball, but a normal force as well. The normal force is a result of the bowling ball's interaction with the bowling lane. The normal force pushes up on the bowling ball. What this means for the bowling ball's vertical components is that they are now balanced, so the ball will no longer witness a downward motion. There is now only horizontal acceleration. Again, this horizontal acceleration is due to the unbalanced applied force. A question one may ask himself is why there appears to be no friction acting on the bowling ball. This is because the bowling lanes are greased with oil, allowing friction to be negligible. Therefore, the bowling ball accelerates down the lane. The second physics topic we are going to discuss is conservation of energy and linear or projectile motion. When discussing energy in physics, we only concern ourselves with mechanical energy. This refers to any combination of kinetic, gravitational, or elastic energy. The law of conservation of energy is one of the most important of all laws in science. It states that while the type of mechanical energy might change throughout the motion, the total amount of energy remains constant unless it interacts with an external force. In this case, the object could lose or gain mechanical energy. When we bowled, we applied a force to the bowling ball to send it down the lane. What this means is that mechanical energy was gained by the bowling ball from our arms. By knowing the amount of mechanical energy gained by the bowling ball, we can then calculate the velocity of the bowling ball as it was sent down the lane. For example, if a 15-kilogram bowling ball is released a half of a meter from the ground, its potential energy is equal to 73.5 joules. In addition, if it gains 46.5 joules of energy from work due to Adriana's arm, then its total kinetic energy will equal 120 joules. From there, the velocity of the bowling ball can be calculated as 4 meters per second. The third and final physics topic that we're going to discuss is conservation of momentum. Momentum in physics can be identified as a mass in motion. Momentum is a quantity that is often involved in interactions such as collisions or explosions. To find momentum, one can multiply the mass of an object by its velocity. Similar to energy, there is a law called the law of conservation of momentum. This law states that in a collision of two objects in an isolated system, the momentum of the two objects before the collision is equal to the momentum of the two objects after the collision. In physics, we concern ourselves with two types of collisions, elastic and inelastic. In an elastic collision, two objects collide, but after their interaction remain two separate objects. In an inelastic collision, on the other hand, two objects collide and become one object, moving together. In bowling, we most often see elastic collisions occur as the bowling ball collides with the pins. The bowling ball rolls towards the pins at a given velocity, and then after colliding with the pins, will most likely slow down while the pins also gain motion. When examining elastic collisions, it is important to understand that the mass times the volume of one object added together with the mass times the volume of the other object will be equivalent before and after the collision. This is illustrated by the following model. For example, a 15-kilogram bowling ball rolls down the lane at 4 meters per second when it collides with a 2-kilogram pin. The pin then moves forward at a velocity of 7.5 meters per second. To find the velocity of the bowling ball after the collision, one must find that before the collision, the momentum of the bowling ball is 60, while the momentum of the pin is 0. After the collision, the momentum of the pin is 15. This means that the velocity of the bowling ball after the collision must be 3 meters per second. And that's all the physics that we'll be discussing for today. So, to recap, we learned about how bowling relates to forces, force components, and linear or projectile motion, conservation of energy and linear or projectile motion, And finally, conservation of momentum.
Go ahead. What? Go.
You said don't go yet.
Super. Got some good curvature on my ball.